Good morning to all of you. We are discussing the important concept in theory of computation, and that is nothing but the grammar. So, up till now, we have seen the importance of grammar. The grammar, which is important for your natural language. For example, in English language, we studied about the alphabets, the characters, then combining our alphabets or the characters, we are forming the words. With the combination of different words, we are forming the sentence, and with the combination of sentences, we are forming the paragraph. But to this particular paragraph or sentences, we must follow certain rules or regulation imposed by that particular language, and that is called as the grammar. So grammar is nothing but your set of rules. So we can say that it is nothing but your set of rules for that defined for that particular language. For example, there must be full stop. There may be some semicolon, inverted bracket, inverted commas will be there, or the use of tense, past tense, future tense. So these are the rules. They are designed for that particular language. So the same manner or on the same way, we can have the grammar for our formal language. And for this particular formal language means the language which we are using for our automata, right? So this grammar is called as our context-free grammar. The grammar which we are studying here for the automata, that is called as our context-free grammar. Now, why it is called as a context-free grammar, that we are going to discuss. Which are the notations used for the context-free grammar, right? And how to use this context-free grammar, that we are going to discuss in detail in the today's session. So grammar is nothing but the rules that involve the meaning, that is called as the semantic, and that does not involve the meaning, that called as the syntax. So you can form a sentence with the help of your sentence, noun and verb. So the two components are there, that is called as the fixed component, and another is called as the variable component. So variable component is nothing but your variables, or they are called as these are called as the non-terminals, or they are called as the variables. And another component is nothing but your terminal symbol, they are called as the T. So two types of symbols. So the terminal symbols are those which are constituents, means they are actually the part of that generated sentence. They are actual part of the generated sentence. For example, here birds, then dogs, then sings, then with all whatever may be the components of that particular sentence, they are nothing but the called as the terminal symbol, right? And non-terminals, in the sense that they are nothing but your variable. Just like we have seen that, for example, in C language, integer a. So int a is nothing but one variable, and this particular variable take any value during its runtime, right? During the execution of that particular program, any value it can take. So a is nothing but your non-terminal, right? And the values which it takes as per the execution of the program, it is called as the terminal, right? So non-terminal are nothing but the variables. So in particular sentence, noun, verb, they are called as your non-terminals or the variable, whereas your dog, run, birds, sings, they are all nothing but your terminal symbol, right? These are called as the terminal symbol. So in this grammar, in English language, rules are defined, the various rules are there, and these rules, they are also referred as the production rules. They are also called as the production rules. For example, one non-terminal on the left hand side, that gives the strings of non-terminals, or one non-terminal on the left hand side, arrow, choice of terminals. So this particular rule, or this particular one, can say that the rule which is written in this particular format, it is called as the production rule for that particular language. So you can have this sentence, these are nothing but the noun and verb. Sentence is given, or sentence is formed with the help of your noun and verb, whereas noun consists of different names, that is nothing but Ram, Sita, Gopal, and verb consists of different verbs here, right? In case of our context-free grammar, in this context-free grammar which we are going to study, so it was invented by the scientist named Noam Chomsky in 1956, and it is nothing but how to define the grammar. It is defined by a tuple, that is nothing but B, T, P, S, where V is nothing but your set of non-terminals. This is nothing but your set of non-terminals. T is nothing but the set of terminals. P is nothing but the production rules. P is nothing but your production rules, and each production rule is of the form, that is one non-terminal that is gives you non-terminal. Means in short, I can write this rule like this: nt gives me nt, means your variable gives you one variable, right? Means here on the left hand side, this is called as LHS of the production rule, whereas this is called as your RHS, that is nothing but the right hand side of the production rule. So the restriction in this context free grammar, restriction in the context free grammar is that on left hand side, of this particular grammar, there must be single non-terminal, and on the RHS there is no such restriction is imposed. Oh, you can have the combination of nt as well as terminal. So you can see here one non-terminal on the left hand side, and there is a terminal string. So you can have nt gives you t dot t. T dot t means you have one terminal, you have another terminal, you can have third terminal. So dot dot dot. In this way, you can have the string of terminals on the right hand side. So S is the start symbol, S is the start symbol, right? Then this is called as a context-free grammar. This is called as a context-free grammar. In this type of grammar, there is a restriction that is imposed on the left-hand side of that particular each production. There must be only one non-terminal. There must be only one non-terminal is given, right? So this is the way to define. This is the way to define the context-free grammar. Now we'll see the notations that are used for the context-free grammar here. See the notations carefully. There are some typical notations used for the grammar. Non-terminals are denoted by always denoted by your capital letter. So remember it, see it carefully, listen it carefully, and understand it. Non-terminal nt, these are always defined by your capital letter. So if there is a capital letter, suppose capital X, capital Y, capital Z, or your S is nothing but your start symbol. So all capital letters, they denote your non-terminals. Whereas your terminal symbol, they are all small case letters: small a, small b, small c, small d, where your small x, small y, small z. So all these are your terminal letters, or these are your terminals. These strings of terminals that is defined, that is given by u, is nothing but your string of terminals. Suppose triple A or V is nothing but your double B. So like this way. Sentential form, that is a string of terminals or non-terminals, collectively contain in U union T bracket star are denoted by DBG, etc., etc. Right? So symbol, arrow symbol, this particular symbol denotes, the production rule. This arrow symbol denotes the production rule, whereas that is nothing but capital A means this is non-terminal, gives you one terminal. So this is capital A, it is nothing but your non-terminal, and small case letter is nothing but your terminal symbol. So this rule is of the form nt gives t, that is nothing but capital A gives B, that is we can call it as capital A produces B. Capital A produces B. Getting this point? Next part of notation is that, say for this particular symbol, this means you can have this symbol here. This particular symbol stands for process of derivation or generation of any string from the language. Means you have to now see it carefully, because you have to solve many derivations here. So for while solving the derivation, while solving this such type of derivation, you have to use this double arrow, or we can have this double arrow, and double arrow in the sense two lines to this particular arrow symbol. So this particular symbol is referred as a derivation symbol, or you can call it as a generation of that particular string to form the language, right? So if we want to derive a particular string, if you want to derive the string, we have to use this particular symbol written like this, right? The next is nothing but, suppose A gives you A dot B. So this is one non-terminal, capital S produces. So you can read like this: capital S produces capital A dot B. So NT gives you NT dot NT, means this is one non-terminal, produces the string of non-terminals. There are two non-terminals, NT1 and NT2. So further you can have A produces the terminal symbol. Now capital A produces your terminal symbol, and capital B, which is the non-T, NT, which produces your small t, that is nothing but your terminal symbol, right? So if S is producing AB, we can derive. So how to derive the string? So here we can have like this: S double arrow gives you capital AB. So capital that particular double arrow symbol stands for deriving in a single step. So S I can write here like this: suppose S double arrow capital AB, because my production rule, this is the first, this is called as rule number 1. See here carefully, this is called as production rule number 2, and this is called as production rule number 3. So 3 production rules are given. How many rules are given here? There are 3 production rules are given. So from this first production rule, I can write like this: S gives me AB, right? So further I can have, so now I can replace this value of A in the first step with this small a, right? So A is replaced here and B will be remains as it is. That is the second step. Now in the third step I can have A and value of B is to be replaced by small b, right? So that I get the string this. Now this is the string because this is the terminal string, right? So we have to find out the terminal string every time produced by that particular grammar, produced by this particular grammar, right? And this AB string means we are finding the AB string, which is very similar to your expression. You have the expression like this: A plus B, or you can have AB bracket raised to star. So this is very similar to that AB bracket raised to star, means 0 or any number of occurrences of AB. Getting this point? So meaning is that while solving this grammar, means we have to solve the grammar, means the production rules, rule number 1, rule number 2, and rule number 3, these are given to you, and it is asked to produce the terminal string. Listen it carefully. Remember, it is asked to derive terminal string. So that's why it is called derive, means derivation. We have to derive the string from the given non-terminal symbol. So every non-terminal symbol must have its terminal symbol. Every non-terminal symbol must get converted to terminal symbol, because this is your final answer. AB is your final answer, right? This is the correct answer. Your non-terminal is not the final answer, because your integer A, means if we compare it with integer A, so in A don't have any answer, or A don't have any value until and unless you assign some value to this A and you manipulate this A value. Up to that, the A does not carry any importance here. So importance is nothing but your variable 5, then 10 or 15. If I assign this value to variable, then you can have the manipulation of 5 plus 10 plus 15. So whatever manipulation or whatever calculation you want to do here, getting this point. So the aim is to find out the terminal string here, and this is nothing but the derivation symbol derived in a single step. Now next symbol stands for the derivation in any number of steps. The means this particular symbol is there, and you have to just put a star mark here. So arrow, double arrow, and put a star mark. That is nothing but the derivation in any number of steps. It is possible. Then you can, so say for example S like this. So I can have AB, means it is nothing but any number of steps I can follow to derive AB string from the non-terminal, that is nothing but capital S. Also that particular double arrow stands for deriving in one or more steps. Deriving in one or more steps, right? So here, now that's all about the CFG notations, means notation used for context-free grammar. Now let us look at the context-free language. Now what do you understand by the context-free language? A language generated by context-free grammar, very simple. The language which is generated by your context-free grammar, it is called as context-free language. Remember this point. So how many languages we have up till now? We have studied our formal language, right? Our regular language or the formal language, the one and the same. Your regular language, you can call it as a formal language, or formal language more correctly or more precisely, they can be called as a regular language, right? And regular language, they are given by with the help of regular expression, or regular expression they give your regular language. Whereas your context-free grammar, they gives you the context-free language. So I can write like this: CFG gives me CFL. CFL is nothing but your context-free language. Getting this point? So if capital G is the grammar with the start symbol S such of terminal capital T, then the language G is the set, that is L of G, that is equal to W, such that W consists of W to the subset of T raised to star, and S gives you W. Means the language, context-free language, is defined with this W, L into the bracket G, that is nothing but the language, context-free language, equal to W is nothing but one word. W is nothing but the word from that particular language, and word is such a way that W is a subset of that particular W, subset of your T bracket raised to star, and S gives you, or S produces W in multiple number of states here, right? So for example, you have the G VTPS, that is nothing but your these are nothing but the set of V is nothing but your non-terminal, this is nothing but your terminal, production rules, and S is nothing but your start symbol. So you can have, for example, if the grammar is given like this, G S B, then this is nothing but your non-terminal, S, capital S and capital B. Then you have AB. These are nothing but the set of terminal, and the production rules are given. This is the one. This is one production rule, and this is another production rule. Means S gives you A B B and S, whereas capital B gives you B B B. Capital B gives you B B B. So if I try to resolve it, or I try to derive it, so I can write like this: S gives me A, capital B B. Now the value of capital B is to be replaced by the string A, and the B value is triple B. So I put here triple B and B. So this is nothing but the final terminal string which I got here. This A, B, 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 right? So we start with the symbol start symbol by the production rule number 1. So that is nothing but S gives you A, B, B. Then we replace the capital B by the production rule number 2. So we can call this is, so always remember, this is nothing but your production rule number 1, and this is production rule number 2. So you have to use and you have to mention which production rule you are using there. Rule number 1, rule number 2, right, like this way. So and then using this production number 2, I can have S equal to ABB. So this is nothing but, so how to define the language then? So this is a language. So I can have I can frame a sentence, English sentence for the language. This is a language which consists of, see carefully, listen it carefully. This is a language which consists of a strings, which consists of a string that always starts with A and end with B. Getting this? The string, the language in such a way that it consists of a strings, and all the strings, they are having the format, they are having the fixed format that starts with A and ends with B. That starts with A and ends with B, and this is nothing but your context-free language. And why it is context-free language? Because this particular language, or the strings which belongs to this particular language, that can be derived from your context-free grammar. The strings that are belonging to that particular language, the strings which are belonging to the context-free language, they are derived from the context-free grammar. That's why it is called as the context-free languages. Getting these points? And this particular string, they are having some fixed format. Already we have seen they have some fixed pattern. Means in case of your regular expression and the regular language also, they are having fixed pattern. They are the same way we are having in case of our context-free languages. The strings of in that particular language, they are following some particular fixed pattern, right? The next point, let us go to the next point, the significance of context-free grammar. Let us see the important points related with the context-free grammar. The very first point is that a language can be represented by two ways. First is nothing but you are using finite automata, and second way is nothing but your regular expression, right? So for example, regular language RL can have your FA. Already we have seen the conversion of finite automata to regular expression and regular expression to finite automata. Both the ways are possible, right? So language can have the representation in terms of graphical representation. We are calling it as a automata, and in terms of mathematical model, we are calling it as a regular expression. So if a language is not regular, see here, if a language is not regular, it cannot be represented by FA or either regular expression. That is clear. If the language, if it is a regular language, you can have the representation by this both way. But if it is a non-regular language, you cannot represent by FA or regular expression, right? So hence there was a need for representing such a language. So grammar is another approach for representing the language. So along with these two parameters, or along with these two factor, there is one more third parameter you can add here, and that is nothing but your grammar. Means grammar, with the help of grammar also you can represent the language. Well, how? Because just now we have seen, so yes, the grammar consists of set of rules, right? And this set of rules you can derive, and after derivation you will get certain string, and that string has certain fixed pattern or certain fixed format, and you can easily recognize what exactly or which exactly is the language. That is nothing but your context free language, CFL language, right? So in this approach, In this approach, language is represented using a set of equations, and equations are recursive in nature. So see here, significance of context-free grammar, a finite automata with the grammar. Now we are comparing here automata with the grammar. See, the table shows you that a finite automata has a set of states. If we compare the grammar with our finite automata, right? If we compare the grammar with the finite automata, we'll find the similarities. The automata consist of states, whereas this grammar consists of set of variables. Right? Then variables in the sense we can call it as a non-terminals, right? Finite automata is defined over an alphabet that is nothing but your sigma. It is defined over an alphabet sigma. Similarly, the grammar is defined over over the terminal. So terminal is nothing but your input alphabet in case of your grammar. Means we are checking or we are discussing the analogy between your finite automata and your grammar, that is context free grammar. And the finite automata has a set of transitions that is nothing but your delta transitions, and grammar has a set of rule that is denoted by your arrow sign. Right? Those here same case is given here states. So in case of your DFA, you can have states Q0, Q1, Q2, whereas grammar you can have the non-terminals, and these non-terminals are your capital A, capital B, capital C. In DFA, you have the input alphabet that is nothing but your sigma, but in case of your grammar, you have the terminal symbol small a, small b, small c. See here, this is very important. Means one way of the language to represent with the help of your automata. Now another way already we discussed, we studied, that is nothing but your regular expression. Here is a similarity we have discussed there with the DFA and regular expression. Now the third way to represent any language, any formal language, is nothing but your grammar. And now we are discussing the way, the comparison between the DFA, that is nothing but automata, and the regular, the grammar and the grammar. And the transition delta, here it is called as the production rules, and here initial state in automata, now it is called as the start state in your CFG, that is nothing but your context free grammar. So remember this point, it is important because yes, we have to have some examples on DFA and grammar, right? Now let us go to the next point in the significance of context free grammar. So see here, if if automata, if the transitions are like this, x, capital X on input A go to final state, capital X on input some input go to final state, then the grammar rule I can write like this. Important, very important, all of you listen it carefully, how the production rules in the grammars are written, or how if there is a question to convert the DFA, to convert the given automata into the equivalent grammar, so the transitions in this particular format, transitions of the particular format, X is one state, on input A go to the final state, the grammar rule is written like this, the production rule is written like this. Now the next one is that, see here again, X, capital X, capital X here, one on input B it goes to final state, on input A it go to self loop, or it is a self transition. So there are two production rules, one production rule is for B and one production rule is for A. So for A, as it is a self transition, so capital X gives you small ax, because it on input A it go to state name X. So if there is a transition from one state to the next state on a particular input, then you have to write down the transition like this, X gives you A into X. This is the way to write the production rule. And this particular, as you know, that X on B to the final state, if it is a transition to the final state, the rule it is written like this, X gives me B. No need to write the final state here, no need to write the final state. And if there is a self transition, and if there is a self transition, then it is simple, X gives you A and the transition is on X. So current state is X and next state, so I can have your current state and the next state, and this is nothing but your input alphabet. This is nothing but your input alphabet. This is the way how we are converting. Means yes, we have to convert the given FA, finite automata, to the context free grammar, So these are the way. The production X gives A. Now read this production as X produces A or X derives A. You can read like this: X produces A, X gives A. I can have X produces A, or X derives A. I can call it as, okay, or X gives A, or X gives A. Three, both, all these three statements are correct. The production X gives A X. The production A gives A X. That is a way of defining a string containing one or more occurrences of A. There are certain restrictions on regular grammar. See it carefully. There are now, if we consider the regular grammar, we have to consider the regular grammar. Now we are discussing our context-free grammar. Now just consider the regular grammar and the restrictions which are imposed on the regular grammar. So which are the restrictions on the regular grammar? So it allows only one non-terminal on the left-hand side, that is LHS, NT of the production, and right-hand side also has a specific form. So NT has here on the right-hand side, there are also some specific form, or there are also some limitations above for the terminals as well as for the non-terminals, right? This restriction is relaxed in context-free grammar. In CFG, these particular restrictions are now relaxed, or they are being removed. In CFG, one non-terminal is allowed on the LHS. No doubt on LHS side, NT must be there, and there is no restriction on RHS side. You can have T, NT, you can have TT, you can have TT, NT, or you can have NT, NT. So any combination on the right-hand side is possible. That's why it is called as the context-free grammar. Context free means what is the meaning of free here? So context meaning of free is that, yes, you can have the, on left hand side you have one non-terminal, but on right hand side you can have any combination of terminal as well as the non-terminal. So that is nothing but the context free grammar. Such grammar is called as the context free grammar. Many features of the language can be described by CFG. So many features can be described by CFG. In CFG, non-terminals appearing in the sentential form can be replaced any number of times by the corresponding production. So we can say that CFG is the more powerful method of describing the language as compared to the regular grammar. So as compared to your regular grammar, definitely your CFG is having more powerful, because in case of a regular grammar you have the restriction NT, and on this particular side you have some fixed format, or here is a fixed format is there. But in case of your CFG, NT is there, non-terminal gives you, so you can have no format or no fixed format is there, or no rule is defined. You can have the combination of terminals as well as the non-terminals, right? The next point is derivations of the context-free grammar are represented in two ways. To represent the context-free grammar, there are two ways. The first is called as the sentential form, and second is called as the parse tree form. So there are the two ways. Means sentential form means you are representing in this format. X gives you AB, right? Then capital A gives you small a, and capital B gives you small b. So this particular format is called as your sentential form. Whereas the parse tree format, means you are representing in the form of tree. So I can have S gives me capital A, capital B, whereas A gives me small a and capital B gives me small b. So this is nothing but your parse tree. This is called as the parse tree representation of the grammar, and this is called as your sentential representation of the grammar. So these are the two grammar representation, right? Okay, so let us conclude here. So what we have learned in this session, that is nothing but introduction to the grammar, the context-free grammar, the context-free language, that is CFL and CFG, notations used for the CFG, and the significance, or we can say the importance of the context-free grammar in the language representation that we have discussed. The course outcome is nothing but to apply the well-defined rules for the syntax verification. So, okay, so let us stop here for this today's session.